Hi, welcome back to our Honors Geometry playlist. Today we're going to talk about some extra proofs that you can use to practice for your Chapter 2 test. So we've got our two-column proof here. Given that 1 and 2 form a linear pair and 2 and 3 are supplementary, I want to prove that 1 is congruent to 3. So let's get our plan of attack down. I want to get the given statements written first. After the given statements, I'll define whatever I can define. And then once I've defined some statements and some vocabulary words, we can identify, is there a segment addition postulate? Is there an angle addition postulate? Is there some substitution that I can do? So first of all, I would put down all my given statements in the given line to start off, but I don't really have a ton of room here, so I'm going to leave that blank and just assume that you can see that 1 and 2 form a linear pair and 2 and 3 are supplementary are my given statements. Step 2, let's look for some vocabulary words. So I see linear pair and supplementary. Well, what does it mean to be a linear pair? If they're a linear pair, then they are supplementary by the definition. Of linear pair. If they're a linear pair, then they are supplementary. They're adjacent and they're supplementary. Step 3, measure angle 1 plus measure of angle 2 equals 180. Because those are supplementary. So these are supplementary. And also these are supplementary. So what does it mean to be supplementary? It means they add up to 180. So those add up to 180. But so do measure of angle 2 and measure of angle 3 by the definition of supplementary. So if you have supplementary angles, they add up to 180. Now step 4, measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Because this stuff right here is equal to 180, and this stuff right here is also equal to 180, they must be equal to each other. And you could call that the transitive property. You could say that you substituted in one thing for another. Either way is fine with me. And then your last couple steps, you should be able to see how you finish that proof. You would just subtract, and then of course you've got to prove that they're congruent, so you need the definition of congruence. This one's a little bit different. The angle QPS, where is that? QPS is congruent to TPR. I want to prove that QPR is congruent to TPS. I want to prove that those two are congruent. So how would I do that? I would say QPS is congruent to TPR. That's given. Okay. Can I define anything? Well, no vocabulary words, but I can define congruence. I can say the measure of angle QPS equals the measure of angle TPR, because that's what it means to be congruent. If they're congruent, they're equal. So by the definition of congruent angles, those are equal. Okay, so I've used my givens, I used my definitions. I need to look for segment or angle addition if I think that's going to be helpful. Well, I want QPR and I want TPS. I don't have those yet, either one, so I need to introduce those by using my angle addition postulate. So angle QPR, measure of angle QPR, plus the measure of angle RPS, equals the measure of angle QPS Maybe I'll change colors for this one. Measure of angle TPS plus the measure of angle RPS equals the measure of angle TPR. And notice that I didn't name this angle right here SPR. I named it RPS for a very specific reason, because it matches up now with that. And of course, SPR and RPS mean the same thing, but it's easier for you to see that that is the same thing if you put the letters in the same order. That's my angle addition postulate. And step 4, is there anything I can substitute? Well, let's look back at step 2. QPS equals TPR. So these two things are equal. So this is a step that is often skipped by students. I would like you to show this step. I'd like you to say QPR plus a measure of angle RPS equals a measure of angle, and I'm going to substitute TPR in there. You could also substitute QPS there. Doesn't really matter. So TPS plus the measure of angle RPS equals a measure of angle TPR. And now you can see that these two are the same. So these two expressions must be the same. So then I have QPR plus RPS equals TPS plus RPS. In your next step, after you substitute that to write your one equation, so I would have this, where is it? This stuff here as my next step. I would say that equals this stuff. And then your next step, you can subtract RPS, and you get QPR equals TPS, and then of course you need to do your definition of congruence. And our last proof, AB is congruent to DE, B is the midpoint of AC, E is the midpoint of DF. I'm just going to assume that you understand that those are my given statements, and I'm not going to write those out just to save time. So let's define some things. AB equals DE by the definition of congruence. Cool, that's done. Now B is the midpoint of AC, E is the midpoint of DF. Well, if B is the midpoint of AC, then what do I know about these two parts? If B is the midpoint, well, if B is the midpoint, then AB equals BC. And if E is the midpoint, then DE equals EF. By the definition of midpoint. And from here, I think you'd be able to solve it. I think you'd be able to finish this proof. But of course, you can keep watching until you feel confident enough to try it on your own. Pause the video, finish the proof, unpause, and check your work. So step 4, you should have DE equals BC. I just substituted DE here. So instead of AB equals BC, I have DE equals BC, and then I also have DE equals EF. I substituted, and then if DE equals BC and DE equals EF, then BC equals EF by either substitution or the transitive property. And our final step, of course, is that if they're equal, then by the definition of congruent segments, if they're equal, then they are congruent. So there's all your proofs worked out. Let me know what questions you've got. Send me an email. Other than that, you can stop by in the mornings. You can stop by during, 4th hour or 6th hour. And I will see you soon.